Again, you can do it the old way, there's nothing wrong with that, but when you start to recognize perfect square trinomials, it takes you a fraction of the time. How do you recognize them? You look at the back. Is it a perfect square? Yes. Then you take the square root times by 2 and we check the middle number. So 49, the square root is times 2, 14. Once you recognize that pattern, you can jump straight to the answer. It has to be a binomial squared. What times what is going to give us x squared? What times what's going to give us 49? Done. Again, if you wanted to do the old way, you'd go, well, product is 49. That's 1 and 49 and 7 and 7. What's the only pattern that's going to give 14? 7 plus 7. So then you're going to write out x plus 7, x plus 7. Then you got to look and say, oh, it's exactly the same. Write x plus 7 squared. I did that in a fraction of a second just by recognizing it as a perfect square trinomial. B. Check out 9. The minute you write down a perfect square, you're going to say to yourself, wonder if this is a perfect square trinomial. Don't assume just because this is a perfect square that it is. This could be any number. This could be 5, it could be 7, it could be 12, and you just have to check if I take the square root of 9 and times it by 2, do I get the middle number? Yes. Binomial squared. What times what's going to give me x squared? What times what's going to give me 9? And I'm going to grab my red pen, if I can find it. I'm going to grab pink. We'll pretend it's red. What do you know about the sign of the middle? It has to match. So this sign is always going to match this sign. Again, if you like the old way, use the old way. This is just saving you some time if you recognize a perfect square trinomial. Show me your thumb so far on perfect square trinomials. Chris, what was this? this tells me nothing. It is kind of jazz handy, but doesn't help me much. Here's the first one that has that coefficient of a. So what you'd do yesterday is you would have started to multiply 4 times 9, and you would have got 36, and then you would have gone, oh my God, there's tons of factors of 36, and I got to list, right. So if you can recognize this as a perfect square trinomial, you've got a shortcut. Now when there's a number in front, there's a little trick to it. We're going to square root the 9 is 3, and we're going to square root the 4 is, and we're going to multiply them together. And if that is double and it equals to the middle, then that's a perfect square trinomial. So sometimes it's not just the last one if there's a number in front. So I'm going to write that out for the visual people. We took the square root of 4 and the square root of 9, which was 2 and 3. We just multiplied them together, which gave us 6. And then we take that answer and double it to see if it gives us the middle number. So it's actually the first times the last square rooted times 2, which will give you the middle number. Perfect square trinomial we know gives us a binomial squared. What times what's going to give us 4x squared? What times what is going to give us 9? The sign in the binomial has to be same as the middle sign here, so we know it has to be negative. Again, if you like the other way, use the other way. This is just a shortcut. D. Can somebody grab the door, please? D, if we did it the old way, you'd go 25 times 4, that's 100. 100 had lots of factors, and you probably just don't want to deal with 100. So if it's a huge product, it's probably an indication it's something else. The minute you have 2 perfect squares, it's probably going to be a perfect square trinomial. So when you wrote down 25 and you wrote down 4, you stop and go, Again, the easiest way to check is multiply them together. So 25 times 4 is 100. Take the square root of 100. Double it, did that give us the middle? Yeah. Okay, so that's another way to test it. First times last. Square root was 100. Check if times 2 is the middle term. So perfect square trinomial says we can jump right to the binomial squared. What's going to give us 25m squared? 5m. What's going to give us 4? And the sign in the middle has to be the same as the one over here, which would be positive. Could you check that? Yeah, you can check all of these answers. So when we have a quiz or a test, you can always check and multiply it back out. If you go back to the question, you know you've done it correct. What is this type of factoring called? Perfect square trinomial. How do you recognize it? Perfect squares. There's 3 terms, yes. And the middle term is the square root of the product times 2. I'll repeat that if you're a wordy person and want the sentence. The middle is the square root of the product times 2. Okay, so the b value is the square root of the product times 2. Second type is always going to look like this, and this is called a difference of squares. What does difference mean? When you have a difference in math, what did you do to get it? That's quotient. Difference is subtraction. So what it tells you is that the middle sign is negative. So you can recognize them because, number 1, middle sign is negative. The middle sign is negative. There's only ever going to be 2 terms in the question. And both terms are perfect squares. Middle sign is a negative. There's always 2 terms, and they're both perfect squares. So let's take a look. Are there 2 terms? Yes. Is the middle sign negative? Yes. Are both of these perfect squares? Yes. What's the difference between these? This has 3 terms. This has 2 terms. This, we don't care what the signs are. This has to be a negative in the middle. This one, they're not all perfect squares. This one, they have to be. This is actually the easiest one to recognize because it only has 2 terms and there's always a negative in the middle. Again, you can do product square, which is what we did your product sum, which is what we did 2 days ago. This is just an easier way to do it. I'm going to fill in this line in a second. We're going to do the first example first. If we were to do product sum, the product would be the C value would be -9, and the sum, which is the coefficient of x, would be, we did one like this at the beginning of class yesterday. Is there any x's in there? No. So what's the coefficient of x? So we think of it in terms of 0 when we're doing product sum. That's what it means, is it's really x squared plus 0x minus 9. Well, what are the numbers that multiply to give us 9? 1 and 9 and 3 and 3. What is going to add or subtract to give us 0? 3 minus 3. So you can jump right to x and x as the first terms. 3 and 3 are the second terms. 1 has to be positive, and 1 has to be negative. That's always difference of squares. So the answer will always be 2 binomials. Typically, x and x goes at the front, or whatever your variable happens to be, whether it's p or q or m. The back is the square root of c. So the second terms are both the square root of c. One sign is positive, and one sign is negative. And that just because of the sum of 0. So we always need one to be positive, one to be negative. Again, you can do this the old way if you like it better. This is just a shortcut once you recognize difference of squares. X squared minus 4. Are there two terms? Yeah. Yes. Is there a negative in the middle? Yes. Are both the terms perfect squares? Yes. So that's called difference of squares. We go right to two binomials. What am I going to multiply to get x squared? X and x. What am I going to multiply to get 4? 2 and 2. What do the signs have to be in the middle? Opposite. Doesn't matter which one comes first, they just have to be opposite. Four x squared minus 1. Are there two terms? Is there a negative in the middle? Are these both perfect squares? So this is called a difference of squares. What's the square root of 4x squared? So 2x has to be in the front, and 2x has to be in the front. What's the square root of 1? So 1 has to be in the back, and 1 has to be in the back. What do the signs have to be? Opposite. Doesn't matter which one comes first. Again, I could have done this with product sum. It's just going to take me 6 steps as opposed to 1 step. 16x squared minus 9y squared. Here's one we didn't even do with product sum because this has a double variable. This would have scared the pants off of us. Difference of squares? How do you know? Two terms? Negative in the middle? Both terms are perfect squares. Square root 16x squared. Square root 9y squared. What do the signs have to be? Opposite. Aren't difference of squares fun? They look so hard. They're so easy. X squared plus 36. Difference of squares. No. Why is this not difference of squares? How do we factor it? Well, let's go back to product sum. We know this is a 0x in the middle. Product would be?
36.
Sum we want is? There's a what? Oh, something on screen, thank you. Sum we want is? 0. Okay, 1 and 36. 2 and?
18.
3 and?
12.
4 and? 5? 6 and? Okay. Any combination to get 0, so let's go in order. Can I add 1 plus 36 and get 0? Can I subtract them and get 0? No. 2 and 18, can I add them and get 0? Can I subtract them and get 0? Okay. 3 and 12. 4 and 9. 6 and 6.
Yeah.
Okay. The problem is, what does the sign here have to be? So that means the two signs have to be the same. So can I add them and get 6? Can they both be negative and get 36?
Yeah.
So if I do -6, -6, is that going to give me 0? No. If I do +6 and +6, is that going to get me 0? No. Why can't I do +6 and -6? Because this is positive. So is there any combination here that's going to get me this answer? So what does it mean about this question? You can't factor. What does that mean in terms of jeopardy? There is nothing we could have multiplied to get that answer. It doesn't exist. There is no combination of numbers that we could have. They'll throw these into difference of squares to try to trick you, because you're just going to be going along square root, square root, square root, and you're going to get to this one, you're going to say x plus 6, x minus 6. But for the question or the answer to be x minus 6 and x plus 6, what does this have to be? Has to be a minus, and that's why difference of squares has to be a minus. So be aware when you're doing difference of squares that it has to be a minus in the middle. 12x squared minus 27y squared. Difference of squares. Does it have two terms?
Yeah.
Yes. Does it have a negative in the middle?
Yeah.
Yes. Are both the terms perfect squares? No. Okay, backup plan. Now we go back to our normal factoring. How do we factor this? And this is a problem. Now that you've learned 5 types, you forget about the very first one. Flip back in the notes. That's why you have a note package. What's the very first kind of factoring we did? Rhymes with I'm an actor. Okay, how do we common factor? This seems like forever that we did this. You have the steps in your notes too. Find the GCF of the coefficients. Okay, so 12 and 27. And 27. Offer of 3. You shouldn't need to prime factor these. It should be fairly obvious that the lowest one's going to be 3. What about the variables? So what's the trick with the variables when we're common factoring? You have steps in your notes. Flip back. Divided by 2, lowest exponent. Different, I heard. Same, I heard. Talk to me more about that. Take the lowest exponent of what? If they are the same. If they're not the same, we don't do anything. So the whole common factor is 3. I'm just writing down what somebody's saying. Well, that's interesting. Where did the squareds go? So if we divide these here, are those squareds going to go anywhere? No. So what's going to be left once we divide by the 3? 4x squared and minus 9y squared. Take a look at this. What do you see? Yes, numbers and variables, more specific. Are there 2 terms? Is there a subtraction in the middle? Are they both perfect squares? So this becomes a difference of squares. That's all they'll try to hide a little sneaky difference of squares in there. They'll put a common factor in first. So what happens to the 3? He's just going to hang around out front. Not worry about him right now. I'm just going to factor what's left. What's the square root of 4x squared? What's the square root of 9y squared? What do the signs have to be? Opposite. There's the factoring for this question. There's what we would have multiplied to get 12x squared minus 27y squared. That's as hard as difference of squares is going to be. Grab the calendar. Let's talk about what's going on in the next couple